Hello everyone. So for this next section, we're going to be talking about triangle inequalities, and you're definitely going to be in for a treat for this one because this is definitely one of the easiest topics that you can learn in geometry, and it's very simple. Really what we're going to be using here is we're going to just decide, given three lengths of a triangle, whether it actually can create a triangle. So as far as the triangle inequality theorem, this is just telling you that the sum of any two lengths of a triangle is greater than the third length. And this is going to be true for all of the sides. So for example, if I look at these two sides of a triangle, A and B, if I added those two together, that has to be greater than that third side, C. And that's true for all of the combinations of sides. So for example, if I look at A and C, these two added together has to be greater than the side B. If I look at these two sides, B and C, those two added together have to be greater than A. All right, so you have to do check that for every combination of sides. So if I look at example 1, it says determine if the listed sides could form a triangle or not. So if I look at this, I'm just going to go ahead and think of every combination. I can combine 8 and 17, 8 plus 17, and those two sides, when I add them together, has to be greater than 24. And is that true? Well, let's see. If I do 8 plus 17, that gives me 25, and 25 is greater than 24. Check. All right, so far we're good. Let's pick another combination of sides. I could also do 17 and 24. If I added 17 and 24 together, are those two greater than that third side, 8? And I could just tell you right now, I don't even have to do the math. I already know that that is going to be greater than 8. Then the last combination I have to do is 8 and 24. If I added 8 and 24 together, will that be greater than 17? Well, I know 8 plus 24 is 32, and 32 is greater than 17. So right here, yes, a triangle can be formed. All right, I'm going to do the same thing over here. If I have 28 and 50, well, let's add those two together. Are those two greater than that third side we didn't add? Let's see, 28 plus 50 is 78, and 78 is greater than 22. So far we're good. All right, well, if I added the other two sides, 28 and 22, let's do 28 plus 22. Is that greater than 50? Well, let's see. 28 plus 22 is 50 itself. So this is a case where no, it has to be greater than 50. And if it doesn't, this is an inequality that's not inclusive. So since both of those equal 50, we can't say that this will form a triangle. So no, it does not form a triangle there. So the same thing over here. If I added 41 and 7, that has to be greater than the other side we didn't add. So is that greater than 35? So far, yes, we're good. Then we're going to do, let's do these two sides. If we added 7 plus 35, well, let's see. 7 plus 35 gives us 42, and 42 is greater than 41. So we're good there. And then the last two sides we'll do, we already did 41 and this and that. Let's do 41 and 35. So if I added 41 plus 35, are those two added together greater than 7? Yeah, I don't even have to do that much math for that one to know that. So yes, this definitely forms a triangle. So let's look at example number 2. This one's a little bit different. This one says find the range of possible lengths for the third side of each triangle. So here what we're going to do is we're going to say, okay, well, our third side, okay, it can have any range of values. It has to be a range between some number and some number. All you're going to do in order to find the lower bound of what the third side can be is you're going to go ahead and subtract 22 and 14. Okay, so 22 minus 14. But then for the upper bound of what the third side can be, all you're going to do is add the two numbers together, 22 plus 14. All right, and this will tell you all of the different possible values that the third side can be. So if I subtracted 22 and 14, that gives me, I can do this in my head, 8, which is less than the third, I'm going to just say third side here. And that's less than, which is less than 22 plus 14 is, let's see, 36. All right, so the third side can be any value between 8 and 36. It can be 9, it can be 10, 11, 12. It could be 35, it can be 34, so on and so forth. So those are all of the different possible values that the third side can be. And then here's kind of a more conceptual understanding of that. It says if a triangle has lengths of 15 feet and 27 feet, check all of the possible lengths of the third side. Well, let's keep this formula in mind. If I go ahead and I have my third side, I know my third side can be anything between the difference between those two and then the sum between those two. So if I did 27 minus 15 versus 27 plus 15, those are all the possible lengths that my third side can be. So I know 27 minus 15, well, let's see, that's going to be 12. And then 27 plus 15 is 42. So my third side can be any number between 12 and 42, not including those two. So does 34 fall between 12 and 42? Yep. Does 12 fall between 12 and 42? Well, it is 12, but it has to be between those two, not including those values. So no, not this one. 29 is between those two numbers. 18 is between those two numbers. 43 is above 42, so not 43. So those are the three values that the third side of the triangle can be. All right. So the last thing we want to do for this lesson, again, because we can come up with a million problems for this and it wouldn't justify an entire class period. So let's go ahead and include another easy topic with this lesson, and that's triangle ordering theorem. So essentially what this is telling you is that the largest angle must be opposite the largest side, right? So all we're going to do is, if we know which angles are the, what the size of each angles are, then we'll be able to know what at least the order of what the largest sides are going to be, right? So this is essentially telling you, and what you need to understand is, we kind of talked about this with the isosceles triangle and equilateral triangles, but we know that this angle corresponds to that side right there. Right? And we even use the same letters to kind of help make sense of that. And we know that this angle corresponds to that side. And we also know that this angle corresponds to that side, and vice versa, right? This side corresponds to that angle, this side corresponds to that angle, and so on and so forth, right? Those are those angles and sides relate to each other in some way. So as a result, if we know the order of the angles from smallest to largest, we will also know the order of the sides from smallest to largest, and vice versa. All right, so let's kind of make sense of this, and it'll probably make more sense when we actually do a problem. For example 3, it says order the sides and angles from least to greatest in each of the figures. So first of all, let's go ahead and order the sides first. All right, so obviously, it says from least to greatest, so we'll start with the smallest one. The smallest side is RS, so RS goes first. Then the next largest side is ST. And then, obviously, from 30 to 35. And then the last longest side is 38, so RT. That's the largest side, all right? Now, what we also got to take into account is the angles. So if I know that RS is the smallest side, the angle that corresponds to that is angle T. So angle T is going to be the smallest angle as a result. 35, that's the next largest side. So if that's ST corresponds to angle R. So angle R is the next smallest side. And then of course the largest side, if this is 38, that corresponds to angle S. So the next largest angle is angle S. So that's the list of the angles from least value to greatest value. All right. So now if we look at the next problem, all right, here it's not, we have to do one extra step, but if we know that if we have two sides of a triangle, two angles in a triangle, we can easily find the third one by adding those two together, 82 plus 54, and then subtracting that from 180, right? So 180 minus that answer gives us 44. So now we know that this angle is 44 degrees. All right. So first I'm going to go ahead and decide what the order of the angle. So obviously my smallest angle is angle Z, right? That's going to be my smallest one. The next smallest one is angle X at 54. And then of course, the last one is angle Y. All right. That's from least to greatest. All right, now let's go ahead and decide what sides those correspond to. We know that this angle corresponds to that side. So the smallest side, based off of the smallest angle, is XY. All right. The next smallest angle corresponds to the next smallest side, which is side ZY or YZ, it doesn't matter. And then, of course, the largest angle corresponds to the largest side, which is XZ. And that's about it. So a nice short lesson for you guys. And, you know, I can imagine the problem set for these problems will take you no time at all. So I'll go ahead and leave that to you. And hopefully this was easy enough. And good luck on the problem set. Take care.